Yeah, so how do you want to approach this? Because I can sort of talk you through maybe what I did to set up the inversion. Or was that?
Yeah, maybe first you talk about what you did, and then I can quick say a few things about the new notebooks, and then we can go from there.
Sure.
So you kind of tell me a bit the tricks of the SimPEG, how you set up the whole thing there.
Sure. Okay, I will share my screen. Let's see settings. Oh, I guess he'll join us. Cool. Okay. Do you see that okay?
Ah, yeah, that's great.
Infinite. All right. So all I really changed was down here. So this here, this invertible. So I'm getting a bit of feedback from you. Would you mind trying to turn your volume down, or if you have headphones that might help? I can do that too.
You talk to me?
Yeah.
Is it better like that?
I think so. Yeah, that's better.
Okay.
Cool. Yeah, so this props.invertible, what this does is it basically keeps track of your property, any mappings that you have associated with that. So, for example, I inverted for log resistivity, I believe. Yeah, so here, we inverted for log resistivity in an active region.
Yeah.
And so we use mappings to basically take, they're quite flexible. You can use a mapping to take like any vector of numbers and translate it to physical properties on a mesh.
Okay.
Domain. And each of the mappings has associated derivatives with it, so that if you go in and update your model, that we actually properly keep track of derivatives all the way to the physical property.
Mm-hmm. Mm-hmm.
And so when we specify this here, this props.invertible, basically what we're meaning here is that you can provide a row map to the problem and invert for any set of parameters that we want to then map to row.
But what's then here exactly the difference between the row and row map?
So row actually, there's sort of two modes of operation. Here, when I call self.row, which I believe I call here, what that does is it actually takes the model and maps it to row. The row map is actually just the pipeline, so it doesn't.
Yeah.
Yeah, so it's just the set of instructions to take M and spit out row.
Yeah.
Yeah, and so then the props.invertible then lets me call self.row. And as long as M is specified and the row map is specified, then I can get this guy.
Yeah. And where you define the row map, this prop invert, or how is it called? There you could add as many as you want. Props invertible.
Yeah. Okay. And so if you want to invert for sigma instead, we can do that. Mm-hmm. Or actually, in this case, any of these parameters that you have specified, we could set those up as props.invertible. And so what's then kind of cool about this is that, say, for example, we wanted to include, let's see. Let's say we wanted to also invert for the source, or be able to invert for the source. So we could do z source map and z source deriv. Props.invertible. And then specify that. So this is just a doc string, so edit the source. And then on the outside, the way that you can interact with this is then either invert for one or both of those things. So here we provided a row map. You could also provide a Z source map. And that would then trigger and say that, hey, Z source is also something that we want to invert for. Or if you didn't want to invert for it and just specify it, then we can say Z source is 3. And then this mode of operation will let you specify it, but we won't invert for it. It'll treat it as fixed.
Yeah. So if you want to have it as general as possible, then you would have to specify all potential parameters to invert in this empymod problem.
Yes.
And then you could later either fix them or invert them.
Yeah. And then with this too, if there's natural default values, we can set them as well. So if there's a natural default 100 or something, then we can leave that in there so that the user doesn't have to specify it unless you want them to.
Okay, great.
Yeah, and then here we can, like, what I would recommend doing for the settings is we can actually just then make those properties on the class and then serialize them before we pass them to empymod.
Yeah.
And so I think that's something that Rowan can help clarify for us with this, basically, because the props makes serializing very easy. So to serialize like a portion of the class is not too hard. Yeah, then here, like, these can all be properties on the class as well. This was me just being lazy.
Yeah.
Keeping it simple for now.
At the end, there's a very fixed set of parameters, so it's not like an open work. It would be.
That's good. Yeah.
Yeah.
Oh yeah. Then the other thing here. So this delete these on model update. So I'm just stashing the approximate sensitivity for each model so that we're not recomputing it. Especially if we're using like second order methods in optimization, because you use it in the transpose, and there's no need to recalculate. Yeah, this is something we'll want to give a little thought to, just how to pick that. For now, I just picked a value and it tried to pick one that'll work.
Yeah. Yeah, and it seems to be quite sensitive to it. I played a little bit around with it, but just tried the min perturbation to change it, and it's quite sensitive to this factor, it appeared to me.
Yeah, and the other thing, like why I guess it's also so subtle, is it's also a perturbation on your model, not necessarily on resistivity. So like we should be giving some thought to how to define this, because in this case, I'm actually perturbing log resistivity, when, like the exponential map. Yeah, so that's just the way that scales. We'll need a little bit of thought, I guess.
Yeah. Yeah, well, I think in logarithmic space, you may not need that kind of percentage, like a perturbation. Probably like just kind of floor, mean perturbation, maybe enough, I guess. Because it's kind of like it's balanced in that logarithmic space.
Yeah, because what I was sort of thinking is maybe something along these lines is do a perturbation times the mean, but then if we're in log space, the mean could be close to 0. And then in that case, we want to make sure we're obviously not perturbing by just 0.
Right, right. But I think just letting that as an input is good, because like it's probably depends upon what is your parameters, I guess.
Yeah, right now, the way you would interact with this, like we might actually want to even make these properties, like properties on the class that you can set. Right now, like the only way that they would change is if you actually are building this yourself. Like JVec doesn't take this.
Yeah. Can you guys hear me?
Oh, hey, Rowan.
Jumping in. Hello, hello.
Hey, Rowan.
Hey, Dieter. Nice to meet you. And Saki, obviously. Yeah, I wonder if putting that on the class and actually having it an array, because if you're, especially with Dieter's code, if it's like not just calculating for the conductivity, because it's like really easy to add other model parameters in there, which may have like totally different scaling.
Yeah. Yeah, that's fair.
And so just like, and I mean, like it could collapse down to a float. But if it's like has the option of being an array even, then you're just saying plus or minus one little thing.
Yeah. This is also something that like I think should actually basically be a util on SimPEG so that it is actually like, you just have a forward modeling engine. It's easy to get finite difference sensitivities.
Yep.
How do you think it will affect, because now we have to calculate 2 forward models. If it would just be made one-sided derivative, you think it's not stable enough?
It's something to play around with.
Yeah.
Yeah, that's usually an option in these like finite difference perturbation side of things, is either you do like a one-sided difference or you do a two-sided difference or central difference. So that's, yeah.
Rowan, when did you jump in?
Like a second before I started talking.
Wonderful. Because the other thing I wanted to ask you, ideally, like each of these should actually be properties. Some of them will make sense to be invertible, some will not. And then what we actually want to be able to rapidly and easily do is serialize like a set of properties and send them to empymod as a dictionary. So, because like all of these settings basically go in as this guy. So that's presumably very easy with the properties library.
Yep. So I think you can. So you can just serialize the class pretty easily, and then that just like pops it into a dictionary.
Yeah.
I think there's some utils in there, or like one-liners really, to filter out like sets of those.
Okay.
Or maybe it's like actually having like a nested settings object that is like set up for empymod on its own.
Okay, so even like
so it's like dot settings dot whatever.
Okay.
I don't know. It's like that would be, could do it either way.
Okay. That's cool. Yeah, and then Dieter, I saw your point on changing what it is that we invert for. So here, like I just stacked real and imaginary data. but we
Yeah.
could actually invert for amplitude and phase.
Exactly, yeah. And maybe even would be good if you could give the freedom to decide if even you just want to work for real or imaginary.
Yeah. So all of those.
Time domain CSEM, you would usually do a Fourier transform to the frequency domain, but then you would just do one or the other with the filter, and then only invert the real or the imaginary part.
Yeah, so we can totally do that. The thing that just comes in there is then we just need to implement different types of receivers. And so like the receiver then being sampling the real part, the imaginary part, amplitude or phase, and then each of those then just has the appropriate derivative associated with it.
Yeah.
And so I can point you to some stuff in the EM code to do that. Or we can even generate an example just inverting for amplitude and phase, or real and imaginary separately. And hopefully that can give you an idea of how that extends.
Okay. Mm-hmm.
One of the things I found, well, I guess there's two things that I sort of found a little unnatural. And I think that some of this will be solved with the forward simulation idea. I don't know if you saw, did you see that issue? I think I tagged you in this. So here, what's interesting is like the mesh that you need is actually very simple. In this case, like you don't actually necessarily need the full-blown SimPEG mesh. There's also infinities that you're dealing with that would make a bit of a mess, I think, in our mesh class. And so like the workaround that I did was like I set just a finite value for the air and then under the hood swap it out for infinity.
Mm-hmm.
Yeah. So, and then that's passed to empymod. And so, which is fine, but it's just like a little bit of a silly way to do that, and perhaps unnatural for somebody who's used to working with empymod and not necessarily SimPEG. And so I think that actually, if we did something a bit along the ideas of what's talked about in this issue, I'll just post it on Slack so that you guys can look. I'll just post it in the EM channel here. So instead of like having this problem survey split like what we currently do, basically having a simulation container that just has everything, and then the simulation is then just like a mix-in on that class that contains everything that you need to get the fields and predicted data. And so this would then sort of allow us to swap out what it means to actually have a mesh, so that you're not bound to using a discretized mesh. It could actually just be a simple list or vector of numbers for the forward simulation. And actually, we could even do that now, just by overwriting what the mesh means a little bit in here. So it would be a little hairy at this point, but yeah, that's something sort of coming down the pipeline that we can clarify later. I don't think it's necessarily a big deal, but yeah, it was just a little odd.
Yeah, I think this with the minus infinity thing, if we later see in the example where I straight used user-facing routines bipole, you don't have to provide that, because then the internal checks will assure that the first layer is minus infinity. So this could already solve that.
Oh, okay.
In the second test, simple, I use just the bipole, so it runs every time the input test. But I did some speed tests, and I think it's marginal, the loss of time, and at least to start, I think we could just use that, and then a lot of that testing and internal calculation we could just get rid of and call empymod.bipole.
Okay.
And yes.
That's cool. Yeah, then here's the stuff we talked about briefly with the mappings. Does this make sense to you?
There you could specify any. How would you specify fixed layers? Here you fix the first two, right? Air and water. But let's say I want to specify every layer except 3 around the target, for instance. You could define that there, right?
Yeah, so in this case, all you would do is then specify the indices of your active layers. So in this example, the 3 that are by your target, and then just define the values for every other layer. And then here, yeah, just then the total number of cells.
Yeah. And in SimPEG, I assume it is, but it's all, you could, specify fixed layers, 3 layers. You could, the data weighting too, if you have different offsets.
Yeah, so the data weighting will not happen here. The data weighting will happen now. I'm going to just pull us to the inversion, because these are just tests to make sure that the sensitivities are working. So the data weighting would happen here. So you could change, in this case, we've assigned both a floor and a percentage. So these will get added to compute the WD. If you wanted to do something fancy, like change all of those values or whatever, you can actually specify on the data misfit. So here there is a WD .w, I think, and you can specify exactly what that matrix is.
Okay.
So it's like details.sdiag of whatever.
And something like, how is it called in the OCOM? Like penalties, so you can free 2 layers from having to be smooth, 2 adjacent layers.
So in that case, that would happen in the regularization. So we've tried to do some cool things with the regularization to let you define different pieces, I guess. So if there's one region that you wanted to be smooth and one region that you didn't, the regularization can actually take mappings.
Okay.
And so I can define, like, if we've got a region that we want to be smooth in this example, then we can specify the mapping that's appropriate for that. And all that would do is just like pull up the indices that you want to be smooth. And then if you wanted to try and apply like just a smallness term, so then we could do reg2 equals small, maybe. I forget what it's called.
Sparse?
No, just smallness. I thought it was simple small.
Yeah, that's simple small then.
Okay.
LE.
Sorry. Yeah, so then we could instantiate like this part, and so this would then, you could again specify, you'll have to give it a mesh. We could specify a mapping.
Okay, that's great.
And then to actually define the regularization is then just now like my new reg. And then if you wanted to put a multiplier between them, like the idea of an alpha, you can do that. So under the hood, it knows basically now when I'm going to evaluate the regularization, I'm actually going to go in and evaluate each of these and add them up. And it does the appropriate step as well with the derivatives and all of that. So DOM has some cool examples of that. If you actually watch the last meeting, he's done some interesting things, both on the mapping side of things and the regularization.
Cool. Those that were the things: weighting, penalty, fixed layers, and also boundaries, bounds. I don't know how to call it. But because I'm thinking from experience, if you start with an isotropic inversion, your stuff can go through the roof very easily now. So if you define bounds on the vertical resistivity cannot be higher than that or not be lower than that, that's possible.
Yeah, so in that case, instead of using like an exact Gauss-Newton, you just need to use a projected Gauss-Newton, and then you can provide lower and upper bounds.
Okay, great.
And that's on the model. So the model versus like resistivity, for example. So if your model is log resistivity, the bounds would need to be on log resistivity.
That brings us to another question, actually. What does it mean we skip the BFGS?
Rowan can answer that, I guess.
Oh man, it's been a long time since I did that. If the update isn't positive definite, it just skips that step. And so like in so you're sort of updating the BFGS matrix through all of these rank 1 updates. And if that update isn't good, you'll just skip it.
So it doesn't mean it skips the whole inversion step.
No. It's just like it's do you update the approximate Hessian as you're going? And if you're going to update it with bad information, you just don't.
Okay, right.
Yeah. Are there other questions you have while we're looking at this, or do you want to take the sharing wheel and show us what you're thinking next?
I'm just checking quick. Yeah, I just out of interest. When did you swap to support Python 3? Because I still remember when I first checked out SimPEG, it was still Python 2.7. That's why I left it on the side, I think, a while ago.
That's fair.
And now, so yeah, you're supporting Python 3.4 upwards, I think, or 3.5. I don't know. When did you swap?
I think that was last summer, like right after the SimPEG conference. Joe did a bunch of work on that.
And how was the transition? Was it a lot of work, or it was quite straightforward?
A lot of brackets around.
Yeah, it wasn't too bad. We're not doing anything like overly fancy. I think there were some division problems that we had initially, but yeah, because we had like pretty good unit test coverage, that actually went pretty smoothly.
Okay, great. Mainly print statement brackets, I guess. I love it.
The market. Yeah, probably one of my comment. I need to head out, so I just because Dieter wants to kind of invert for anisotropy. So in the JApprox, so we probably need to do a similar thing that we did for like a frequency domain EM inversion, kind of inverting both mu and sigma. Because like we probably need to break apart JVAC to or JApprox to a JApprox something, and then we may need 2 different function, I guess.
Yeah. Well,
maybe
will be different because like the way we did it for the frequency domain, yeah, there's a get a derived signal, get a derived smooth. So absolutely.
Yeah, although here we may not need, we just need a different, like just check which parameters we have, and then like rather than just using row map, we could just put it in like that anisotropic map in.
I guess I would not invert isotropy, but vertical resistivity to keep the properties similar. I think if you invert for horizontal resistivity and anisotropy, you might get a weird weighting between the two. That one influences more than the other, and probably it's better to invert for horizontal and vertical resistivity and calculate the anisotropy from that. But something to be.
Lindsay, on this one, can you just, instead of that calc FM, can we just like do the mapping inside of that? Because then that code is like completely generalized.
Yep, absolutely. Yeah, so this then just
takes the model.
Yeah, that's really fair.
Yeah, because then you're
Oh, okay, that's a good point. Right.
And then you can actually pull that JVEC stuff out into a utility, and then as long as that perturbation side of things is also a property, then it's just go a little bit to the left and right of every model parameter.
Right. Yeah, then that's actually much easier. That's cool.
That's agreed. Yeah, and then Peter, to the point about vertical and horizontal resistivity versus inverting for the anisotropy and vertical resistivity. That's something that would be interesting to play around with, and actually can be achieved through the mappings, and because the sensitivities, like the sensitivity should take care of that difference with the scaling.
Maybe.
But I don't know. It would be interesting to see, because in that case, like what you're changing is the space in which you're searching.
Mm-hmm. It is, yeah. I think if I would start again, as we always say, I would probably make the input data horizontal and vertical resistivity, but it isn't. But still, yeah, but that's a detail. But I think one of the things it might be interesting for SimPEG is to make this, I think you mentioned it, to make this derivation function much more general, so it's not just for empymod, but you could use it for any modeler that has no derivative and throw it into this Jacobian function of SimPEG to get a numerical derivative. I don't know.
Yeah, absolutely. I think that would be very valuable to have. There's a lot of different cases, and even within SimPEG, like if we want to invent this type of stuff like that for a first pass before we actually go and derive everything, it might be nice to be able to just play around with this and stuff. So.
I see so it's still cold in Vancouver.
Not cold, I think. Not that cold.
It's been a lot.
Yeah, so it's pouring in these days. Okay, Dieter, I need to go. So I'll see you later.
See you around next time, and then in that case, if I don't see you before you defend, all the best and good success.
Thank you a lot. Thanks a lot, Peter. I'll survive. Bye, Rowan. Bye, Lindsay.
Bye-bye.
Cool.
And congrats to you, Rowan. I saw you post that. It's official now.
Yeah, no, I'm super stoked about that. It's good to be on the other side of.
Now you're on video. Is it limited to 3 people? Hangouts?
Oh no, I just turned on my camera.
Ah.
You were hiding before?
Yeah, exactly. Yeah.
Cool. What else? Yeah, maybe just if you want to have a look at the other example.
Yeah.
A simple test. I don't know. How do I share stuff?
So if you sort of scroll over onto the left-hand side of the Hangout.
Showcase screen share.
Yeah.
That's it. And now you can see it?
Yes.
Ah, great. Terrible newbie. Okay. So as you saw, I played first around with the first test with the dipole, and I thought, well, it's so straightforward, we better just use the bipole. It might be a bit slower, but it's much more general because dipole is just infinite small points along the major axis. And bipole, we can have whatever you want. And then I did first the second test and wrote a custom function for the inversion. And then afterwards I thought, well, maybe all these input tests are not that costly. And I think they are not. And so when you look at the simple tests, so then I just call them the plain function of empymod bipole. And then this makes it easier in a way that you don't have to define a lot of other functions we had to define beforehand. Let me quick check. Because you had there to calculate zeta h, zeta v, eta h, eta v, and all those stuff. And if we just call the bipole, then we just have to give in frequency, anisotropy, the horizontal and vertical electric permittivity, blah, 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 the usual stuff we give into bipole. So I think it's a bit easier from that side. Then I tried, you had there a note, this will likely to be generalized. What did you specifically mean with that?
Oh, just because the one example that I looked at just assumed that the number of data only depended on offsets, I think. So like it depends on, of course, your number of sources, receivers, and frequencies.
Yeah, so I think this is probably the normal, the generalized version. So number of sources, number of receivers, numbers of frequencies, times 2. So yeah, we still have to generalize it more to decide whether or not it's real and imaginary, or just real, or just phase, or who knows what.
Yeah.
But other than that, it should be okay. And then
go back to that for a second.
Yep.
Because this brings up a point, Rowan, that I'd be curious to hear your thoughts on too. Because right now, if we implement receivers for this class, for the survey, like receivers as an idea don't actually exist on the list. And I'm wondering if we actually want to tease that apart a little bit.
What do you mean?
Yeah, because what we've done in the past is we've always had like a, and then that source knows which receivers are listening to it. Which is just different conceptually, like the way we've layered it in SimPEG is a little conceptually different than I think it's layered in empymod.
Well, I mean, can you repeat it? Sorry, I just understood it very badly.
No problem. It's a little confusing. So we have, when you set up a survey in SimPEG, we have a source list, which contains whatever sources you're using. So in a frequency domain problem, let's just assume we're doing a 1D download, but we're going to do different things. So in that case, one associated with each frequency. And then each source then contains a list of receivers that are listening to it. So if those receivers are measuring real data at 1 hertz, that's attached to that source.
Okay.
Whereas when you're specifying sources and receivers,
these are just basically coordinates.
Yeah.
So in the bipole, yeah, it's x, y, z, where each it's x1, x2, y1, y2, z1, z2. In the most extreme case, to have an arbitrarily rotated finite length dipole.
Right.
And then this basically, if it's rotated in any direction, then you basically have to calculate all the combinations, the x-directed source for y-directed, x-directed, and z-directed receivers, and so on.
Right. And then sort of conceptually in SimPEG, what we would do is then also tease apart the fact if it's listening to real or imaginary or amplitude or phase.
Mm-hmm.
Yeah. Rowan, do you have thoughts around that? Do you know what I'm getting at, or is that too convoluted?
Yeah, I guess it's probably all wrapped up in the same call in the empymod. Is that what you're saying? And like,
well, what I'm saying here is that like his sources and receivers, like all of your receivers are listening to all of your sources. Is that correct?
You're asking me? Or
yeah, Peter.
Yes, it's like each source position is received by each receiver position. Yeah.
Yeah. So then, like that sort of extra layer of
is there like a way to not have that happen? Like if one of the receivers was not listening to one of the sources?
Oh. In empymod. No. And with the current functions, no.
So actually, I wonder maybe if we are doing that, then we could just like use empymod as a driver and then like have that separation of receivers and sources outside. And so each one of the sources actually has its own empymod driver.
That would be, yeah, that would be absolutely sensible, and it would probably be the same speed, because internally in bipole it will just loop over it. Like, yeah, that's because
so just do the loop on the outside.
Yeah, because the kernel, the wave number domain calculation can anyway only handle one source depth, one receiver depth. And as soon as there are different ones, you have to loop over the kernel. So it doesn't really matter if you let empymod loop or you loop in SimPEG.
Does that make sense, Lindsay? So you're actually like attaching the empymod really to the source side of things. And so each source is a new problem that we're passing down to empymod, and then just like listening to whatever data is attached to that.
So then the okay, so if we're in the field, we would still do a loop over sources and then just calling the empymod for each source. Is that?
Yeah.
Okay, cool. Yes, that makes sense.
And I'm also guessing that like starting up empymod is like, is there any sort of caching on init of the thing, or is like init to run versus like init and then run it multiple times? Is there a penalty hit there?
No. empymod is really, from the coding, really simple. Let's say there's no such stuff as caching or intermediate step saved or anything.
So in which case that could actually happen at like the for loop level, probably, Lindsay, is like actually spin up like an instantiation of whatever the init of empymod is every single time for every single source.
Yeah.
And then you don't actually have to attach it to the source class in SimPEG. It can still be in the simulation class. It just gets run and started up every time like a source is found in the loop.
Yeah.
Mm-hmm. I mean, that's also the difference between the two main routines in empymod is dipole and bipole. And bipole is just, these are just loops looping over the required source to signals. and if we do the looping outside, then we could just use dipole, which is just, as I said, infinitely small poles in the main directions, and then we can do the looping and the summation of the different source receiver signals in SimPEG. That would also be possible.
Are both of the do dipole and bipole take the same inputs?
Pardon?
Do dipole and bipole take all of the same inputs?
Almost. I made a diff because I was interested in that myself. The only difference is how you specify source and receiver. So in dipole, you just specify X, Y, Z, and it's just one X, one Y, one Z. And then you also have to define which component you want, the AB that's coming from the paper by Hunziker, who called it AB. So it's 11 is for X, 12 is for X, Y, and so on, 13 for X, Z. Whereas in bipole, you define a source by X1, X2, Y1, Y2, Z1, Z2. So you don't have to give the components because it's already given from the coordinates. But then you have to specify whether or not your source is magnetic and your receivers are magnetic or not. And you can specify how many points you use to integrate over the line. And you can give a strength, which is in the end just a multiplication.
Okay. So
there is one argument in dipole that is not in bipole, and there are 5 arguments in bipole that are not in dipole, but that's all.
Okay. So what we could actually do is have, like, we can solve this so that you can run it either way, just by each of those being a different source class. And then the source then has to just have its own inputs that are appropriate for either dipole or...
Yeah. You see my screen now, so yeah, there's it.
Yeah. So that's super cool. Yeah, so we can run it. There's no reason we couldn't either.
Yeah, that definitely would be good, even if we with time would have all the looping in SimPEG, but if we have both, then we could compare the two.
Yeah.
And see if if they give the same result, which they should.
That's cool. So I'm wondering if we want to start, if we get some of this code into a repo somewhere, to start like generalizing a bit, and go from there.
I know how you work with branches, or how do you do that stuff usually?
Well, I guess I'm wondering first off where we put this, because the Scratchpad I just sort of see as like a place where we have some code, but we could do like a like start a repo on SimPEG and call it like plugin empymod or something like that.
Yeah.
Well, I mean, like, can we just keep on working in the same thing and eventually just change the name of the repository? And so like pulling the functions out into whatever and like slowly create the library instead.
That's fair.
Yeah.
What do we want to import?
I have no idea. SimPEG-empymod or something.
Sure.
Because like I think like some of this stuff, like once we abstract like the JAPROX piece out, then that will probably migrate over to SimPEG probably in the utils side of things. And so we can like just like slowly pull pieces and make it into a library.
Okay.
Yeah. Call it main for now.
That sounds good.
And actually, like I wonder if even this stuff just goes into empymod in terms of like throwing the SimPEG adaptation in there, possibly.
What do you mean?
So that like you can, if you have SimPEG and empymod installed, you just say empymod.simpeg survey or something, and just like have it in there, so that the sort of adapters for that library specifically are just with that library.
What I was thinking of, I have the empymod, which is just the kernel kind of, and the user-facing routines. And then I have the other repo, which is empyscript, where I have add-ons, let's say. One is a TMT mod split, and now this filter designing tool. And I thought I will create there an add-on inversion, and then I could load in their SimPEG, but not directly in the core thing.
Yeah, that's fair.
As an add-on.
That's fair.
That was my idea. That was my question as well. How did you guys think in SimPEG how to include it?
I wasn't entirely sure.
If it more like just as notebooks as example it works, or if it would be in that you could load it up, fire it up, or.
I think it's something that we want as like a package that you can load up. It's just a question of where that lives. And I sort of like the idea that we put it somewhere that's like sort of separate from both, so that you can import both. But like if you are only interested in fluid flow, then in SimPEG, then you don't have to install extra packages. And then similarly with empymod, if you're only interested in the forward, then
yeah, I guess it would be sufficient. Like if you call the module, it will check if empymod is installed, and either it will, if not, it will tell the user to install it or try to install it itself.
Yeah, and so I think we can put it sort of either place, and there's pieces of the JAPROX that would be handy to have in SimPEG, and I'm sure there's pieces handy in empymod. But yeah, for now we can just kind of work from the current repo.
But so you will move the repo?
No, let's leave it in the same place for now, and then we can. I think like where the code lives, perhaps will clarify as we keep going.
Yeah. Well, I didn't search, to be honest, but do you have any examples so far for like a 3D model and you do a CSEM style survey, like EMGS style or node-based?
Yeah, we don't really have any examples like that.
But it's doable with the code at the moment.
Yeah.
It would be, well, once it would be established, it would be really cool to have this, to use SimPEG for a 3D model, do some 1D profile inversions, and then create a 3D starting model from that, somehow the standard CSEM way of processing data.
Yeah, that would be super cool.
And then do a 3D inversion. But actually, most of your examples, are they 1D inversions or are they 3D inversions but potential data? Or what is the speed if you would do a full 3D CSEM inversion?
It's not that scalable yet. We haven't like parallelized the code, so that's sort of that's a slowdown. But we do have octary meshes in place and things like that. So the forward simulations run reasonably quickly. So like we couldn't do a production scale marine CSEM inversion in 3D yet.
No, just wondering, what is the...
Yeah, but if we've got like a line or like a few lines of data, it should be doable.
Yeah, so, okay, cool.
Yeah. But we've done, and we've done both. There's an example in the EM paper where we did like 1D inversions and stitched them using just the cylindrical mesh. So we inverted that. And then we did a 3D, we didn't do an inversion, but we did a sensitivity calculation piecing example.
How different is it? Well, I guess you would have to run tests. If you do a 1D inversion with cylindrical mesh versus a layered mesh.
Yeah, I mean, that's something we can compare.
Kind of interesting.
Yeah. Yeah, because
in the 1D case, it should be the same, but then it will be the question, what if your data is 3-dimensional? Yeah.
Yeah, so it's That's one we could play around with, which will be interesting because once both of these are plugged in, like switching between sort of using the SILMesh or empymod. Would be.
Well, I don't think then it would be interesting in this sense of like potentially with students at work who are interested in a bachelor or master thesis to just play around a couple of weeks or months.
Yeah.
To do these kind of comparisons to with no economical benefit, but just interesting from an academic point of view. Cool. Well, I would be really happy if you could do these weighting, penalty, fixed layer boundaries, just examples, even if they are commented, to kind of keep me going to play around.
Yeah, sure.
And then I don't know what would be the best step to go forward.
I think the first thing is if we can get this like initial implementation, we'll get it started as a package, just in this same Scratchpad repo, and then because then we can import it and start building other notebooks that are a little more concise and show like a simple example of weighting or those.
Yeah, definitely make it possible to have to choose one or two parameters to invert for horizontal, vertical.
Yeah.
I didn't see if anything sensible is coming out.
Yeah, that sounds good.
But the first results were really cool. I mean, I see all this output with the least squares 1, 2, 3, and then skip BFGS, but I didn't check what is really happening internally, though.
Yeah.
So it looks okay.
The LS is the line search, so that's telling you like how it tried to take a step and then.
What does it stand for? It's not for least square. It's not for the norm.
Line search.
Line search. Okay. Yeah. I thought it uses different norms. Then I was wrong.
Just letters, you know.
As I said, I didn't dig any further.
I think the optimization code has been on my radar to like clean up for maybe 3 years. So, and the outputs would be the first hit on that.
It's better you finished your thesis than you finished the optimization, I guess.
Yeah, I think so.
What I was missing in this thing, just from what I'm used to look at, is there is no timing in the inversion function, is there?
There is under the hood. I think it's through we have like a counter class that you can attach to the inversion, and then it just like records anything that like has either a count or a time on it.
Okay,
so
you print it out like all the other stuff.
Yeah.
Okay.
I don't know if we have any examples of that.
No, I don't think so.
It's just something that, well, at least in CSCM inversion codes, you always see.
Yeah.
How long did the beats actually take? Because usually you start them and you walk away, and then if you want to know if you're going to do it again or not, you have to see how long it took.
That's a good point.
Yeah. Anything else, right? No, I was surprised because you said you made it simpler, right? You put it shallower and thicker.
Yeah, just for the single frequency, it was.
Then once I had this multi-frequency, I thought, well, I want to see how it is, and it didn't seem to have lots of problems. So
that's good.
That's good.
Yeah, and then playing around with the regularization parameters is interesting. It gives you a good feel.
Yeah, I guess.
Sensitive to that as well as beta. So there's a few different routines. I think I left one commented. The directive called beta estimate, or estimate beta by eigenvalue. So what that actually, because you can specify, there's a few different ways you can play around with beta. You can specify a fixed value. You can use a cooling schedule. So if you want to start with a high beta and drop it. And then if you don't specify a fixed beta at the beginning, you can use this beta estimate by eigenvalue. And what that'll do is basically hits both your regularization and your data misfit with a and tries to estimate their eigenvalues, and then like takes the ratio to pick a beta that makes them comparable.
Mm-hmm.
Yeah, so you can fiddle with as well.
We'll give it a go. Yeah, what else? I think that's all from my side. I might be playing around the next few days a bit, and then, as I said, most of February I will be offline due to visits from home. So yeah, what I get done next week, it will get done, and then we see us again in March.
Well, I'll try and get at least a first pass of scraping some of this code, and we can put it in Python files and at least have something to hit on that we can.
And I saw you're going to meet the PyChimley, some of them. You had it on Twitter, no? PyChimley, how you call it?
Yeah, so I met with Florian like way back, well, when we were in Bonn, because he's in Bonn. And
yeah.
What's kind of cool is he's actually going to be in Berkeley for 6 months when I'm supposed to be there as well.
Okay.
That'll be a good chance to hopefully pull out some common pieces and start to share a bit more code. Because right now both of them are just huge packages, and it's hard to actually do anything together when
combine things. Yeah. So empymod is a good playground because it's very simple, straightforward. So
yeah,
it's a good first step.
Good.
Neat and tiny and little, and because I think that it's interesting because you have these big projects. You have quite an overlap, but then quite a region that don't overlap. But then how to make them work together is probably a headache.
Yeah, something to give some thought to for sure.
But so you're gonna meet him in Berkeley when you move in summer, you said?
Yeah.
Yeah. Okay.
So still a bit of time.
Cool. You have anything else, or Rowan?
I don't think so.
No, not from my side. Nope.
All right, cool. Well, we can try, if there's anything else that comes up next week, we can certainly catch up again or be in touch over.
Yeah, we could meet before Thursday, so like Wednesday would be good, or Tuesday. So yeah, but we see how we progress. Sure, if it's worth to have another chat.
Yeah, that's very fair.
Cool.
All right. Well, have a good evening. Thanks for the chat.
Thanks. You too. Both of you. Bye bye.
Bye bye.